Patrick. Hey, who do we have in Howdy Partner today?
How you doing, Shardul? So today we have Pulumi. They're going to be showing us some amazing work that they're doing, and I'm excited for this episode. It's actually my first time on here, so it should be pretty sweet.
So, actually, would you like to introduce the chat to what Pulumi does?
Uh, Absolutely. So Pulumi, they actually have what they're going to be showcasing today is they are forerunners in the AI world, and they're going to be pretty much showing us their AI and their insight offerings that they have, and pretty much how they can use and leverage this for their like for example infrastructure as code, and how we can take advantage of those type of technologies. So definitely stoked and excited to see what they have to show us today, and yeah, I'm fairly as far as green on this. So I'm sure I'm going to be learning a lot, just like our viewers.
Awesome, awesome. So let's invite our guests on, Luke and Megan. Hi, Luke. Hi,
Hello.
Megan.
Hey.
Hello, guys.
So, would you like to introduce our offering today? Since Pulumi.
Yeah, sure. I can kick things off, and then I'll hand it over to Megan as well. I'm Luke, CTO here at Pulumi, and we've been building infrastructure as code tools for the cloud generally, and obviously AWS specifically for the last 5 years or so. I also worked at AWS for a little while, prior to that, so I had a chance to sort of work on EC2 and sort of core cloud compute things. So we've been working on core infrastructure as code and providing great building blocks for folks to build, really complex and big and capable systems on top of AWS and other cloud technologies. And I think the thing we came on today to talk about was some of the new things we've done around, Pulumi AI and using AI tools to help you kind of learn how to use the cloud effectively, and insights, which is some new work we've done to make it easier to go understand all the stuff you have under management in your cloud across your different regions and cloud providers and that sort of thing. So going to show off a couple of those things and maybe answer some questions and go a little bit deeper on Pulumi itself. And then I'll hand over to Megan as well to introduce herself.
Yeah, hey everyone. I'm a product manager here at Pulumi, and I've been at Pulumi for about a year and a half, and I focus primarily on the Pulumi Cloud, which is our managed service. And before that, I was like Luke, I was also at AWS. I was a PM there in the databases team. So familiarity with your guys' world, and it's good to see you guys. And today we'll just be talking, like Luke said, I'll be talking about our search feature, which is on Pulumi Cloud. And so we'll get to show you a little bit, and you can ask questions, and we can demo it live.
Cool, cool. I'm hearing a lot of infrastructure as code. Would we like to introduce the chat to what that is all about?
Yeah, sure. So, I mean, let me do high level, and maybe I'll just actually, jump in and demo a little bit of sort of the core Pulumi experience even before we get into some of the new things. So I think, infrastructure as code, probably a lot of folks, working with AWS are obviously familiar with the basics of infrastructure as code, things like CloudFormation, or maybe you've used Terraform or some of these other tools before that allow you to sort of describe the cloud infrastructure you want to manage in, a desired state. So here's what I want to manage, and then for me to sort of update the infrastructure I am managing to that state. And this provides a sort of really reliable way to manage a lot of complexity. You don't have to point and click to make changes. You don't have to write scripts which manually bash on your infrastructure, and potentially if something goes wrong, they get out of sync. You can just have a single place where you define in code, and you can version control that, you can code review that, all that sort of thing, to manage your cloud infrastructure. And I think in practice, pretty much every organization today managing really large scale, complex, highly capable cloud infrastructure deployments is doing that using some kind of infrastructure as code, tool. That's really become effectively the standard for how you sort of tame the complexity of cloud and leverage it to your advantage. And I think with Pulumi, which we kind of introduced, 5 years ago or so it's a relatively newer tool in this space than CloudFormation and Terraform and some of those others. I think the big difference that we've taken with Pulumi is that we've kind of embraced the idea of using kind of traditional programming languages, like TypeScript, Python, Go, .NET, whatever you want to use. And you can use these to sort of get the software engineering benefits these languages provide, right? There's amazing tools that you get for, building scalable pieces of software for testing your code, for componentizing your code, for having reuse, having IDE productivity, all of these things. And we kind of know that these are the tools you need to build really, high scale systems. And so we want to bring those into the cloud and make them available for AWS, for other cloud providers, for other SaaS providers that you might be using. And so that's effectively, what Pulumi is at its core. And then we provide a whole bunch of capabilities on top of that to sort of help engineering teams at large sort of manage all of the different cloud infrastructure that they're deploying. And that's part of where the Pulumi Cloud offering we have kind of layers on top to help with that. And Megan will show some of that off a bit later as well.
Awesome, awesome. So you're essentially saying infrastructure as code, and in extension, Pulumi lets you apply these pre-existing software engineering best practices to infrastructure management and to the cloud, right?
Yeah, exactly. And we've seen how these same tools, these same programming languages, these same IDE tooling, these same higher level frameworks, these have enabled us to build enormous and complex applications for the desktop, for mobile, for the web, for backend services, for all these other domains. And yet, up until the last few years, we kind of haven't leveraged those tools in the cloud infrastructure space, which is arguably even more complex and even more capable. And so really, we're kind of just trying to bring the best of software engineering into the cloud space to sort of help folks to build more impactful things and get more value out of the cloud.
That's awesome. I've been hearing a lot about this cloud formation thing that AWS has, and I hear it's all defined in YAML. Why the choice to go with SDKs and using traditional programming languages instead of just going the YAML way, or some other domain specific language?
Yeah, I think the biggest thing is kind of that these languages are a kind of a way to gain all these software engineering benefits that you're used to from other environments. So you get strong typing and the ability to get IntelliSense as you're typing. You get the access to the ability to create reusable abstractions. So instead of copy pasting, you can sort of give a set of related functionality a name and reuse it instead of reinventing it every time. You get to use the best of the libraries available in those languages. You get things like for loops, which seem simple, but hey, there's no concept of for loops in cloud formation, right? I think now, 10 years in, they're kind of working on a design for these that maybe will appear at some point, but it's one example of all the just sort of richness you get from kind of using existing programming languages. And the more complex and the more capable the infrastructure you're trying to manage, the more you need all of these tools. And so we found that the best approach is not to sort of invent yet another domain-specific language, but to leverage the best of what kind of the software engineering industry has built up generally, and that's to embrace sort of traditional programming languages. Maybe I could just show my screen and we can kind of do a little demo to kind of show that off.
Absolutely, let's jump into it.
Alrighty, so I think this should be showing a kind of a VS Code IDE right now.
Yes,
we see. You guys seeing that? Perfect. Okay. Mm-hmm. So yeah, so I mean, this is an example where I've just started in a kind of a Pulumi program here, and I'll just kind of write some code from scratch to show what's going on here. If you've ever worked with TypeScript or Node in this case, which is what I'm using, you'll kind of recognize most of this, my package JSON, that sort of thing. The only thing that's sort of unique here is we have this Pulumi YAML file, which just says, the name of my project and what runtime it's using. And so we support a variety of languages, Node and Python and Go and .NET, and even a YAML format, which we can talk about a little bit later. But other than that, it's just a normal TypeScript program. And so here I'm going to kind of write some code. And one thing I'll note just before I go is I actually have, this is not the primary. We'll talk about sort of Pulumi AI's offering a little bit, but just to sort of double up on the AI stuff, I have Copilot installed into VS Code here, because one of the benefits of using existing programming is you get all the tools that are available in our IDE environments. And that includes things like, GitHub's Copilot. And so you'll see that kind of showing up as I type here, that I'm getting some AI assisted, Copilot hints here. But let's say I want to sort of create an EC2 instance, right? So I can do something like this. I can say new EC2 instance. You'll see kind of if I use Copilot, it suggests some things here. Not particularly exciting, and I don't get multiple choices. I just have to kind of effectively take what it has. But I can write out some code like this, and this is sort of using the Pulumi SDKs. So this is an AWS.EC2 instance. If I go and, kind of get IntelliSense on that, you can see, just the enormous number of APIs that are available from within the AWS platform, which just has tens of thousands of different APIs I can work with. And so everything that's available in the AWS cloud is available here from within Pulumi. And then all this is strongly typed. So if I, tried to pass, a number here or something, you see we get that error message. I can't pass a number as the AMI. If I tried to do the same thing here, it knows that I need to pass sort of a dictionary of values for the tags. And so we get all that kind of traditional support that you expect from kind of your ID and that productivity for working with these things. And of course, even things like, inline help text. So exactly what I need to know to use each one of these properties that I'm getting as I go type this. And so that general idea that you get all those benefits is really true. So once I've written a program like this, I can come in here and do a couple of things. The first thing I do is write a Pulumi preview. And one of the things that makes this different from just a normal imperative program is that I'm able to, both deploy this, but I'm also able to preview what's going to happen if I make a change. And so in this case, I'm not actually going to deploy this code yet. I'm just going to ask what would happen if I deployed this. And so here it says I'm going to, create this EC2 instance, and it's going to have an instance ID that's not yet known, saying it's an output of string. And if I come in here and say, Pulumi up, we'll see that now it'll actually redo that preview, and then it'll ask me, do I want to do an update? And if I say yes, it'll go ahead and actually deploy this into the cloud. But of course, it has this problem, right? That the image ID does not exist, and that's because Copilot sort of completed this and didn't know what I was working with, and so I could do something a little bit more advanced, like I want to get the AMI. So maybe I call I'll just use this API, and we'll let it kind of complete this again. Now we'll go and run this again, and we'll see this will again say it's going to try to deploy that. Oh, I never fixed this to use that on. So this is one of the key things. We can kind of use the outputs of this and pass it into the inputs of this. So this ID, from this call is what we're going to use. So we don't have to hard code in that value. We can kind of get it from the environment from AWS directly. This will take a couple of seconds, but should actually kind of deploy that instance into AWS.
So what is this? What is this AMI you're pulling?
Yeah, so I mean, it's an interesting thing because I just used Copilot instead of coming up with it. But this is the, I believe this is the owner ID for AWS itself. And so this is AWS's, standard HVM instance for Amazon Linux. But yeah, if I wanted to go kind of define exactly what I wanted, I'd put some additional filters in here to pick up a more, more explicit AMI. So yeah, and that's the kind of thing, when we go over and kind of talk about Pulumi AI, we can kind of ask for it to do more interesting things in terms of figuring out what to use. But that's a quick kind of look at kind of Pulumi itself. We can just sort of define our infrastructure, manage it. Here we created that instance, and it's now running kind of in AWS. In fact, we can kind of go click on this link here. This will dive us over into the Pulumi cloud where we can see sort of some more information about what we deployed. And in fact, it has sort of all the resources, including that instance here. We can see all the metadata about the instance, like its IP address and that sort of thing. But we can also click on this link and just dive right over into AWS itself. And so we can see this is that EC2 instance running inside AWS. So really easy to get from the CLI directly into that one resource through kind of deep linking. But yeah, that's a quick kind of tour of Pulumi itself. But potentially we can go kind of talk a little bit about kind of Pulumi AI as the next step as well.
Actually, while we're here, so how do you all build your SDKs? Like, do you just take all the resources that are in CloudFormation and then like convert them into handwritten like methods that Pulumi like the SDK brings in, or do you have some other fancy method to do that automatically?
Yeah, it's a great question. So we actually have two different providers for AWS, and we kind of have two different general approaches that we can take to kind of bridging providers into Pulumi. And we have around 130 different cloud providers, and sort of when we talk about cloud providers, we sort of mean the long tail of sort of cloud and SaaS solutions. So GitHub is one of them, and a variety of other kind of tools and SaaS products you can integrate with and coordinate in the same way. But of course, AWS and the other major cloud providers are the biggest things that we work with. But we have two approaches. We have a provider model, so anyone can go build a provider. They basically just define what create, read, update, and delete will do for that resource type. And so there's a documentation of how to build those providers. And then we provide bridges, one bridge that lets you take any kind of Terraform provider, because it's a large open source ecosystem of providers that are built for kind of the Terraform model for create, read, update, and delete. We have a bridge that lets you map any of those over into kind of the Pulumi model, so you can expose SDKs in all the Pulumi languages for any Terraform-based provider. And we do that for quite a few ourselves and put those in our registry. But then we also have a native provider interface, and we've gone and built our own native providers for AWS and some of the other major cloud providers. And our AWS native provider is actually built on top of the new or relatively new Cloud Control API, which is sort of I don't know if everyone here is familiar with that, but it's a AWS service that effectively takes the sort of bottom half of CloudFormation, the piece that describes all the resource types in CloudFormation and how to actually provision them in the cloud, and makes that available as an API that anyone can invoke, create, read, update, and delete, and list operations on. And so we use that to provide sort of a consistent model of the entire AWS platform that we can just automatically generate. And so we've been working with the teams at AWS on that for many years, even well before kind of that was released. We're continuing to work closely with them to make sure that we can use that to provide a really great experience for AWS users.
That's awesome. That's awesome. But yeah, you said you have two different providers for AWS Classic and I believe it was Native. So
Yeah.
what is the difference between those two, and how, like, is there, let me put it this way, is there a difference of features? Should I pick one over the other for just because one is better than the other, or so like, yeah, how are they different?
Yeah, so the AWS Classic is the one that's based on that Terraform AWS provider. And so that one, has been around, the entire time that Pulumi has existed, and is where sort of still the majority of Pulumi usage is on that. The AWS native provider is the one that's built on top of Cloud Control API. And that one is still in preview, largely because we're just waiting for Cloud Control API to kind of get to critical mass coverage of the platform. And that's something that the AWS service teams are hard at work on and making tons of progress on. And so we're expecting, kind of in the next, N months or maybe the next year or so, that we will transition to that being the primary provider once it sort of has coverage of the entire platform. But right now, we still sort of encourage folks to work with the AWS Classic provider, which has access to sort of the vast majority of what's available in AWS. The native provider, has the benefit that, when there's new features in the AWS platform, they're available immediately. It's like same day support within that AWS native provider. And so you can mix these two together. And so for a lot of folks, they use AWS Classic for most of their things, but then if they really need access to something that isn't yet available there, they can be effectively guaranteed that's going to be available in AWS native and just use it from there.
Right, and because it's just a library inside of your programming language, you just import it as something else, and you're good to go. It's a
Right.
whole other client, and it's a whole other provider. That's awesome.
That's cool.
Yeah.
Cool. I have a question.
Go on, yeah.
Yeah.
So I love the story with how you guys are using AWS's CDK and things like that. I'm curious. Does Pulumi itself cloud run on AWS native? Like, is it totally on AWS, or I'm curious about the architecture of your solution.
Yeah, so I think there's sort of two pieces. One is the pieces I just showed were mostly kind of the open source, the CLI and the SDKs and that sort of thing, and that piece is all just open source, dev tools that you kind of go and run locally on your machine. But then right at the end there, I did show off kind of clicking on that link, going into app.pulumi.com, which is our Pulumi Cloud backend, That's technically optional. Folks can use, Pulumi's open source offering without using that and just storing that state locally, and then they don't get sort of those features from the back end. But we do, allow you to use that, and we have a free tier for individuals, and then offerings for teams and enterprises on that. And that service, that backend app.pulumi.com service, that does actually run in AWS today. Runs, fairly standard sort of, ECS plus some managed data services inside AWS. And so, we probably go deeper on that as well at some point. Kind of, I think Megan may just incidentally kind of show off a little bit about how we use Pulumi within the product a bit later. But yeah, no, we run, a fairly large scale kind of AWS service in production for actually running that Pulumi service. But that said, Pulumi itself can kind of work with any cloud provider. So we have lots of customers, obviously, kind of using AWS, but we also have many customers using Pulumi for other clouds as well, or mixes of clouds.
A really cool experiment would be, because we're playing with Pulumi AI, we could have it think up the architecture for Pulumi and see how close it is to the real one.
Right. Yeah. No, that's interesting. Maybe that's a good transition, actually, to talk a little bit about some of the stuff that's new for us with Pulumi AI and Insights.
Yeah. Actually, while we're doing that, I think Fulrig had a question saying AI is like the hot stuff now, and he heard it's gonna take his job away. What do you have to say about that as CTO and obviously major figure? So what do you think?
Yeah, I mean, I do think it's it's definitely the hot stuff right now, and I think there's other of these kind of hype waves that you can be a little bit skeptical of. This one, I personally think, just practically speaking, for just so many people I know, it's changed their day to day in meaningful ways already. And I think that the idea that it's going to change people's experiences in a lot of different places, even more so in the next few months and years, is I think hard to deny at this point. So it's definitely hot stuff, but I think maybe more justifiably than some other recent trends. And in terms of the taking my job away, at least in the foreseeable future, I don't think that's really the kind of the interesting, piece of this. I think the interesting piece is really like how can we kind of use these tools? I mean, we're just getting amazing new productivity tools. You even saw that, when I was just showing even just Copilot, which is GitHub's offering, or AWS has Code Whisperer, and all these tools. They're just an extra tool, right? That's kind of helping you as a developer to just sort of accelerate, think a little bit ahead, get some in context help. They're kind of like, just the next iteration of IntelliSense and of hover tips and of all these things. And I think, just the idea that, hey, these are all just some additional tools that are going to help you to be even more productive, to have even more kind of superpowers as a developer, I think is the right, mental model for me to think about them. And as someone who, enjoys building tools for developers, it's just a cool new set of technologies we have to go use to try and do that, right? To help developers be more productive.
Yeah, that's brilliantly said. But yeah, with that, let's jump into Pulumi AI.
Sure. Yeah. So I guess back probably about a month ago, maybe a little over a month ago, we kind of launched Pulumi Insights, which was a set of kind of new offerings and technologies to kind of help you to gain more insight into your cloud infrastructure. And one piece of that was Pulumi AI, and maybe I'll just jump over and kind of show this in action. So, if you go to Pulumi.com, you can see, Pulumi AI right here, and this drops you over into just Pulumi.com/AI. And this is, kind of that chat interface. But really the idea here is, one of the things we noticed with kind of cloud infrastructure generally is that the cloud platform is just truly enormous, right? The complexity, the scale of what you're trying to do with these cloud platforms is really fairly unprecedented. Even when you look at other domains of kind of programming, you look at building, maybe iOS apps, or you're looking at building web applications, or you look at building kind of Node.js applications. And in all those cases, the APIs that you're working with are actually meaningfully smaller than what you've got available for you in the cloud providers. And even just with Pulumi, we have hundreds of thousands of resources that you can use, and millions of properties that you can sort of fine tune and configure. And just understanding that, figuring out how to use all of that is really sort of an intimidating challenge for a lot of folks. And so I think one of the things we've noticed is a common challenge for folks to use Pulumi and really to use the cloud effectively is, hey, I have this idea about what I want to build and maybe some of the technologies I want to be involved. How do I go figure out how to combine those technologies, how to use technology X plus technology Y with these things configured this way to solve the problem I want? And typically that's a sort of go do a Google search or something, go find something, copy paste it in, see if it works, tweak it until it kind of actually meets my requirements. And that's just a challenging content problem for us. Like, how do we go build all the content for all the millions of different things we might want to do? And so I think one of the promises for Pulumi AI is really, hey, we don't have to go generate every single one of those combinations. We can just when a user wants to know how to do something, we can have these AI tools actually just directly give you an answer that's at least a very good starting point, to potentially a sort of a complete solution to the problem that you have. And so maybe I'll just do an example here. So this is our Pulumi AI tool, and so take kind of the same prompt that we had suggested there. Let's say I want a static website on AWS with a CDN. I'll just hit generate program. You'll see it just thinks for a couple of seconds, and then it just goes and authors that. And I will say a couple of things. I'm going to be demoing some AI stuff, and of course, these are non-deterministic. I don't know what it's going to come back with, and that's part of the fun of these things, is that they're very creative, and we're going to get sort of an interesting solution to this problem that, quite likely, I have not ever seen this exact solution to this problem before. And so, we'll see what it comes back with, but we'll let it kind of write this thing out. But you see it's kind of figuring out how to write some code for this. It's also the performance of these things that sometimes can take a while. I'll come back to some pre-canned examples later. But they're typing at a speed that's faster at least than a human. So we're kind of creating this example on the fly, even faster than I might be able to do it myself. But certainly, we wouldn't mind if it was even a little bit faster. This is all based on using kind of OpenAI's APIs to interface with GPT-4 in this case.
Awesome. While it's generating all of this awesome code for us, we had a question in chat asking us, the IntelliSense used in the demo, was that Pulumi AI behind the scenes, or was it just a normal VS Code plugin?
Yeah, the piece I was showing earlier, that was just GitHub Copilot. And so that was, just installing that plugin into VS Code and using that. Could you get a similar experience with Code Whisperer or some of the other sort of IDE integrations that are available. And so I think, for me, I kind of like using both. I like using that for just completing a piece of code. And then things like, Pulumi AI are a way to go kind of solve the whole problem all at once, and really with a directed guidance. And one of the key things with Pulumi AI is, we're not just using kind of a large language model to generate this code. We're also seeding it with sort of knowledge of what all of the resources are that are available. And so let me just kind of come over and show you the Pulumi registry here. We have the Pulumi registry, which has 136 different packages here for a wide variety of different cloud providers and SaaS providers. And Pulumi AI actually has access to all the information in here. So not just what the providers are, but if I come into AWS here, for example, we can see there's dozens of different modules, and then within each of those, there's quite a few different resources available. And for each of those, there's then a whole bunch of examples and properties and descriptions of these. And so all of this metadata is available to the Pulumi AI tool to go understand exactly what the shapes of these APIs are, and then let the large language model with Pulumi AI actually use that information to generate a program here. And so I started building this actually in Go. I might actually create a new one in TypeScript just because Go is a little bit more verbose, and so it'll take even longer. But you can see in this example, kind of creating quite a few things. Was using AWS config. It's creating a security group configuration. It's creating a new website here using the static website component. And so I'll let this kind of maybe go on for a little bit, but creating a full kind of program here.
Yeah. Is the config actually talking to the AWS service config, or is that just configuring like a client on the program side?
Yes, in this case, I haven't followed this exact program yet, but it does look like this was trying to use the actual AWS config service. And so this is the aws.config service here. But let me pull up some other examples that maybe, this is one kind of that, just so we don't have to wait for it. This is one that I ran kind of earlier today. And this is an example where I said, run a container in AWS exposed to the internet and using TypeScript as a language. And you'll see kind of it, we articulated what the problem was, how it was going to solve that problem, and some of the packages it was going to use. So not just the AWS package, but AWSX, which is a set of extensions we have to do things in a simpler way, and the Docker package that it was going to try and use to build a Docker image. And you can see it came back with this piece of code that actually sort of combines those things together in an interesting way. And I don't even know if this is a very kind of interesting kind of solution where we've got some user data on the EC2 instance. Like, even though we said we wanted to run a Docker container, kind of decided, hey, the easiest way to do that is probably just spin up an EC2 instance and run Docker run inside it. And so that's sort of an interesting solution to this. But hey, this is a complete solution that creates the security group to expose this, finds an AMI like we did in the previous example, boots up an instance. Points at it, kind of sets up Docker on there and runs it, and then kind of ultimately runs an Nginx image. But the really interesting thing I think about the kind of conversational interface here is that you can then say, hey, if I don't like what I got, or if there's something it didn't quite get right, I can sort of guide it towards fixing that up. And so in this case, it said, be sure to replace your key name here with an actual key name. And maybe I want it to just go ahead and help me out with that piece as well. So I say, create the key name for me and build the container image locally to render hello world from Nginx instead of just running the default Nginx Docker image. And so you see it comes back and it sort of re-articulates, hey, what am I going to do to make some changes to this? And then goes and writes, modifies that program. You see most of it is sort of the same, but it adds in the pieces it needs to sort of address the feedback I gave it. So it defines the Docker file content here. It actually creates the key pair, and now it's just asking me for what public key I want to use so that I can access this. And it then goes and modifies this to run a Docker load. Actually, this is a solution I would have never even thought about, to go sort of store this content, build it into a tar, and then load it up inside this image. So kind of interesting, it's coming up with solutions to these problems, taking feedback on things that it gets wrong or that you want to do slightly differently. And continuing to kind of iterate on those things.
Wow, I love that. I love the fact how you can. It not only gives you the code, and it takes in the more input that you put in, the more precise and accurate it gets. I also love the fact that it has the comments and everything, so exactly what it's doing. So this is pretty sweet. This is definitely a dream for a developer.
Yeah, I think it's exactly right. It's not just the fact that it's generating the code, it's the fact that you can kind of interact with that code in a rich way. And like you said, the comments and things like this is a great tool for learning, for exploring, for iterating on something, and for kind of getting tips on how to, modify something you've already done to meet a new set of requirements. And I'll just jump over to a couple of other ones that I kind of pulled up earlier that might be interesting. And by the way, I'm clicking on these links that I have, for previous conversations. You can also come in here and just click the share conversation and copy link. And that'll give you a permanent link like this that you can share with anyone else so they can see a conversation you had. So if you come up with an interesting solution via this tool, you can go share that with other folks, and they can go see the full thing directly within Pulumi AI. And so this is an example where I said, create an OpenSearch cluster and use it from an AWS Lambda program. And so this is something, I personally haven't kind of stood up OpenSearch before. And so I would have had to go look at the docs on this, go find an example and copy paste something over. But instead I can kind of get a simple example that it proposes here for, fully working OpenSearch domain. It gets all of these property names kind of correct and uses them in the correct ways with the correct types. Here it's a Boolean, here it's a number, here it's a string. And then, it knows how to set up the IAM configuration to give it a, fairly specific set of roles where it's just about operating on Elasticsearch. And then finally, to run a Lambda function. And here it actually, is actually embedding the code for the Lambda function right in line here. So we've got a fully working Lambda function written in Node that I can run within this thing. And so I've deployed OpenSearch, we've written the code. It even mentions that it didn't, I think up here it said something The Lambda function example does not execute any OpenSearch queries, but it is provided with the environment variable. And so, hey, we could probably go from here and say, hey, can you add some code to, actually insert some data into the OpenSearch cluster? And we'll see what that could do, but it'll probably take a few seconds to do it.
Be sure to switch it into TypeScript.
Oh yeah.
So we have a question from chat. If you can open another tab or something, how would Pulumi AI create a application using the LAMP stack?
Okay, let's see. I haven't done that one before, but it's part of the fun of these is just seeing kind of what it does do. I'd be curious what approach it takes. I think one of the things I often find is interesting to sort of have a prior, like what would you, if you were solving this problem, use, and how does that compare to kind of what the AI tool comes up with?
Yeah.
And so it sounds like it's actually going to use Lightsail to deploy this, which is a sort of interesting choice, probably a simpler way to kind of get this stood up. But I guess I actually did not know this. I guess Lightsail comes with a LAMP kind of pre-installed blueprint.
I believe it does. Definitely not the way I would have done that. That's extremely interesting. Okay.
So, and say, yeah, and the other interesting, it mentions that the program uses this AWS Lightsail instance configured with a LAMP blueprint, and you can even click on this link here, and this will go directly over into our documentation, which gives you the full documentation for this resource. So if you want to go learn more about that resource, you can do it in there. But if I say, could you use EC2 instead of
Lightsail? Yeah.
Lightsail. I assume it'll kind of figure out how to rewrite this and do it in a more bare bones way.
Yeah, I mean, left up to me, I would probably end up using ECS and some kind of managed database. But yeah, EC2 is perfectly fine too.
Yep. And so you could take it in that direction as well, and see what it goes from that direction. But yeah, so I think you can come back to this maybe in a second. But yeah, I think generally you can kind of see this pattern of it being fairly creative about how it can solve these problems, and oftentimes coming up with solutions that do take a slightly different approach initially than I might have thought, but maybe it'll expose me to a new way to solve that problem. And then if I don't like that way, I can guide it back into something I'm more comfortable with. But if I do like it, maybe I've learned kind of a new approach to solving one of these things. And that approach is obviously informed by kind of everything on the internet, not just the Pulumi code, but kind of all of the understanding that these large language models have built up about cloud technologies generally, and AWS specifically, and infrastructure as code, even more specifically. So they have a sort of a wide array of knowledge that they're kind of applying to these problems.
Makes sense. Actually, I would love if it could help me solve one of my actual problems in my job. So, how would it create a like an IoT data ingestion pipeline?
Okay, that's another thing I definitely have not done.
And chat, please, if you have any suggestions for Pulumi AI to take a crack at, paste them in chat, and we'll run them against Pulumi AI and give your opinions on it.
And of course, you can do this as well. You can just go to pulumi.com/AI and try these things out. And if you find something you like, share a link to it back in the chat, and we can bring it up here as well. But yeah, it looks like Kinesis and IoT thing and IoT topic rule are kind of the key pieces it's going to use. And again, we can kind of, even before it's kind of come up with a solution, we can go open these up and see what these resources are all about, and kind of what the core documentation for these things is. But probably take a few seconds for it to build this whole thing out. But now, one of the interesting things, I haven't gone and tried to run any of these yet. And of course, it's not guaranteed that these are all going to be fully correct. But why don't I just come over here and take this example for instance, and copy paste it over. And one thing you see is when I copy paste this over, there's no syntax errors or anything like that. So it got the TypeScript code is all correct, all the types are correct, and so at least that layer, it's something that should work. And so I can come over here and just see, hey, what happens if I run Pulumi up on this? And I'm expecting this won't necessarily work. It doesn't always work 100% out of the box. But if it doesn't, we'll kind of see what it looks like to kind of modify that. So it does say we're using a deprecated API, so I could go fix that up, but let's just leave it like it is for now. And of course, we see that we're deleting that old instance we were managing and creating this new security group and instance. So let's just let it do that.
Yeah, and I guess that's an example of how. Your key pair
it actually told me it needed to do that. So yeah, I guess this is exactly the thing in the previous example I suggested it kind of go do, and I don't have one set up, so I won't go the rest of the way. But you can kind of see, hey, that's the error there was something, and I could even do something like this maybe isn't the best example of this, but I'll just do it because it's sort of interesting to see. I can just tell it, hey, I got this error. Can you fix it? If I don't know what to do about that. And now it's going to be creative about how to go and modify this code to sort of address the potential cause of that error. Yeah, so it's going to now create a key pair itself.
Fascinating.
So won't go let that finish off. I want to make sure we can touch on a couple other things, but definitely happy to come back and do a couple more kind of Pulumi AI things in a little bit. But I think that's sort of the core of the kind of Pulumi AI tooling, and seen pretty amazing kind of uptake and usage of this by a lot of Pulumi users. It's just sort of a great substitute for having to go find just static content out there on the internet that only solves 50% of your problem, and then you've got to go the rest of the way. Being able to have just an assistant that can build these things on demand for you is really pretty amazing.
Definitely. Actually, going on that, I think we saw an excellent reason why infrastructure as code is fun, because when you kind of deleted the code for the old instance, Pulumi realized that and was like, hey, we should probably delete that old instance because it's not required anymore. So yeah, that's just one more reason why infrastructure as code is not just cool, but also kind of required, because you can now put in like security or like access control based on that, where you can go like, hey, this user really isn't allowed to delete instances. What are they doing deleting instances?
Right.
Yeah, just yeah.
I also think that.
Yeah, no. Okay.
I'm sorry. I was going to say, I also think that it's great with cost saving as well. So you don't have any, just VMs and instances just spun up for no reason. So it's a great way to clean things up as well.
Yeah, and it's actually probably a great transition over into kind of what Megan was going to talk about, because I think that cost saving, kind of understanding what you have under management and kind of and how you're managing it across all the different environments you're working in is sort of one of the big challenges that we find people have, and infrastructure as code helps because it lets you kind of structure the way you're managing that. But we often find people need additional kind of tools to sort of gain insight into their cloud infrastructure, even on top of that. And I think that's some of what we've done recently with Pulumi Insights and Resource Search. Maybe I'll just hand over to Megan to talk a little bit about that.
Actually, as we're leading into that, Fullrig posted an amazing little comment. Version control before infrastructure as code, and version control after is just implicit. So excellent point. But yeah, Megan, go on.
Sure. Let's get into it. All right. So feel free, same as with Luke, feel free to jump in, ask questions. Yeah, it can be really casual throughout. So from our Pulumi homepage, there's this Pulumi Cloud link at the top, and you can get to it from there. But a lot of our customers go straight through the CLI, like Luke showed with his first EC2 instance example. And so just to give a quick overview of what the Pulumi Cloud is, Pulumi Cloud allows you to manage your Pulumi state. And for anyone not familiar, Pulumi state is basically just a checkpoint every update that you run with infrastructure as code that shows all of your resources at that time. And so for Luke's example before, his state would have been just that EC2 instance. And then once he ran the new Pulumi AI program, all those new resources would have been the next version. And so one of the great features of using Pulumi Cloud is we handle all that versioning for you. So if you want to roll back to a previous version, you have an audit log of all of that. It's also really helpful if you're doing postmortems or if you have business continuity or compliance requirements in your organization. So at a high level, that's one thing that Pulumi Cloud does, but we offer a lot of functionality on top of that we've built with our customers over the last 5 years. Things like having role-based access models. And so we have the concept of teams, and you can have all these different teams with different access to different stacks, just to ensure that you're allowing the least privilege across all of your stacks. You have this simple dashboard which shows who's updating what stacks, how your resources are growing over time across, your various cloud providers, and you can see your members and some analytics of what resources you have by provider. And so what I'm showing here today is actually Pulumi's organization on Pulumi Cloud, which is a little bit meta, but we actually use Pulumi to deploy Pulumi and host Pulumi Cloud. And so this is actually our real organization where we store all the state for our cloud resources. And so we're demoing you something very real here today. And just to walk through kind of at a high level, allow you to get the lay of the land for Pulumi Cloud. When you run an update on a stack, you get a log of all the updates that have been run for that stack. And then from there, you can kind of go into the logs and see what changed in that update. You can quickly see. And so if your colleague is working on something and they have a failed update and they're not sure what's happening, they can just send you the link and you can see. So for Luke's error before with the key value error, he could have sent that to me, and then I can open it up and see the error he's running into, and we can debug it together. So, Pulumi Cloud enables you to just collaborate with your whole team and have all these features on top of using infrastructure as code. And as Luke was talking about, we recently, about a month ago, released this Pulumi Insights kind of high-level bundle of features, and I'll talk about a couple of them today. And so one of them is resource search. And so this is something that we had heard from customers quite a bit, is they'd be managing, we work with teams that manage tens of thousands to hundreds of thousands of resources. And, intentionally, if you're within an AWS account, it's a walled garden. It's hard to search across and see all these things. But then also you might be using Snowflake, Datadog, GitHub, all of these things with your infrastructure as code. And so you want a single place to view all of it and be able to do analytics on top of all of it. And so about a month ago, we built this feature, or we released this feature, resource search, where you can now search across all of it. And so we'll kind of demo things live, and feel free to give me, searches you might be interested in. But, let's say I'm interested in just a bucket. I can search and be like, okay, I can see here are these S3 buckets. But I also get these aggregates at the top. And so I can filter down by specific aggregates. And maybe I know the bucket name, so I want to search just for AWS S3 buckets, and I'm looking for a specific bucket by name. I can get to that. And so let's say, a good example of one of my use cases recently for resource search is Pulumi Cloud has an audit logs feature where we log everything that happens in your organization and dump it to your data warehouse. And so in our case, we dump it to an S3 bucket, and I was trying to figure out which cloud account that was in. And so all I had to do was just look for our bucket, which I forget the name of now. But and then you can just see what AWS account it's in. And similar to what Luke was showing before, you can go straight to the AWS console. So I can just go straight to that account that has that bucket and jump into it. And so in addition to being able to just find something you're looking for using resource search, you can also get a quick kind of aggregate view of your data. And so when we demoed this for the first time to some of our customers, immediately looking at this page, they would say, oh, we actually have like a lot more resources and staging than we thought. We should go, look at what's happening there, because immediately this gave them an aggregate view and analytics over their entire cloud usage, regardless of which provider. But you can also do things like look by team. So in our case, we have a data engineering team. We can filter by that team and see, what's this team doing? You can filter by their last like created or modified resources to see what's recently been deployed by this team. It opens up a lot of interesting use cases for being able to understand your data.
So we have a quick question from chat.
Yeah, go for it.
Autobot SVE is asking, how is Pulumi AI different from ChatGPT? They see that it's connected to GPT v4. Is the Pulumi dataset something different, or does it encompass like a superset of the GPT dataset?
Yeah, so I can speak to that. So I think there's sort of two key ways that it's different than ChatGPT. I think one is that although it's using the GPT API underneath the hood, it's not, or the OpenAI APIs with the GPT-4 model, it's not using ChatGPT directly itself, and so it's not that same interface. We've kind of built our own interface around this, and then there's two kind of things on top of that. One, we're doing prompt engineering to make sure we guide it towards the problem of writing infrastructure code, giving it a whole bunch of sort of static kind of support for solving that problem. So you don't have to go kind of recreate all that every time you want to interface with ChatGPT to give it the context on how to write code kind of using Pulumi. But the second and the more fundamental thing is the way that we give it access to, before it goes and uses the ChatGPT style kind of interface, that we go look up a whole bunch of information from that Pulumi registry and infuse that into the prompt that we give it. And so it's effectively as though you did a multiple step pass where you as a user thought about your problem, thought about what some of the key technologies were, did a Google search or search in the Pulumi registry, found the top 10 most relevant segments, copy pasted them out of the registry, pasted them into your ChatGPT prompt, and then asked a bunch of clarifying questions, and then submitted that. And so you could kind of do all that stuff, but we just go do all that for you, and then give you a nice interface around that whole solution. And so that means that if you go compare what Pulumi AI is going to do versus ChatGPT, and ChatGPT is a great tool to use just generally for kind of domain, for general problems. But when you want to kind of write Pulumi code, you're going to get a much more accurate, much more up-to-date answer from Pulumi AI, because it has access to all of that, the most up-to-date information about how to use those APIs from within the Pulumi registry.
Awesome. And we do have another question. Is there anything inside Pulumi that is policy as code that enforces certain standards and or best practices? And following up on that, can it be generated with Pulumi AI?
Yeah, so on the first part, yes, there is, and in fact, you can kind of see it on Megan's screen. And maybe I'll hand over to Megan to kind of show a tiny bit of that off inside the service there. But we do have a policies code offering for Pulumi. Today, Pulumi AI doesn't kind of explicitly help with authoring those. It can do a little bit of it, but it's not tuned yet to be ideal for that. So it's something that we want to augment, both to have policy authoring things in the Pulumi registry and to have Pulumi AI be able to help explicitly with that task. So definitely something we're exploring, but it's not quite there today for Pulumi AI at least. But I'll let Megan kind of show off a little bit of what we do with policy in the Pulumi Cloud here.
Yeah, so another one of the features of Pulumi Cloud is policy as code. And I feel show you something like this is just looking at an example of the code itself. So some examples here, this is just our AWS TypeScript policy example, is doing things like discouraging EC2 public IP addresses, and you can have two different types of warning: an advisory warning, which basically every time a Pulumi update runs, it'll just warn anyone in your organization that this is the case, so they're aware of it. And then you could potentially do something like do an advisory warning in development environments, but in production, have it be a blocking policy. And so for this example here, require a name tag. So name tag is required and mandatory, meaning that the update won't run if there isn't one. And so, you can see prohibit public internet. You can have like S3 buckets not allowed to have their ACL as public. You can choose what resources can and can't be deployed in your organization. There's a lot of optionality within policy as code, but here's an example of some of the things that you can do.
So, just a follow-up on that. Does this define policy specifically inside Pulumi, or does it go below that and define, I believe it's AWS config rules that essentially set account level guardrails?
Yeah, this is within Pulumi's context. Okay, go ahead, Luke.
Yeah, exactly. This is Pulumi specific. So there's actually a couple of benefits to that in a sense. By doing this at the Pulumi level, it means it's actually running even during those previews. So before you've deployed anything into AWS, you're getting this validation done against what you're proposing deploying, and so you can get really early validation of that. You can get that even within your IDE. You can kind of get that information bubbled up, and so because Pulumi is the thing managing the actual deployment to your cloud, we're able to run and catch those things early. And so although it is Pulumi specific, but it actually runs, you saw when I was running Pulumi up, I was running that, on my local machine. Of course, that might happen in your CI/CD system or even, Pulumi's deployments offering. But if wherever you're running Pulumi, it's going to actually run the policies right there. And so this organizational enforcement here is going to push those policies down and enforce that any Pulumi client that tries to preview or update the stack must run those policies before it can actually do the preview or update.
So okay. So can you define? Let's say you're a new developer to Pulumi, or like just new to the cloud, or well, experienced in the cloud, new to Pulumi. If you wanted to define policies locally, but you didn't want to use the UI, are you still able to do that, or is that something that is exclusive to like the SaaS offering of Pulumi?
Yeah, so we have, the SDK, the code examples that Megan just showed a second ago. Those are all available and can be used as part of the open source project. And you can, use those directly from when you run Pulumi up. You can say, -- policy pack and point it at a folder where you've defined some policies. So you can do that yourself, and you can use all the policies. The one thing that the Pulumi, the Pulumi Cloud offers that sort of it layers on top of what the open source offers is that sort of organizational enforcement piece. The idea that for all the stacks managed by the Pulumi Cloud, we can push those requirements that you must run this policy back down on. So it's sort of I think generally the Pulumi Cloud is useful for organizations and teams working at scale. We don't try to keep any of the raw sort of capabilities out of the open source, but for things that need sort of coordination and collaboration, and they need that backend service to manage that, those are the things that sort of require working with the Pulumi Cloud.
That's awesome. Yeah, sorry. Continue, Megan.
No worries.
More about search and insights. Yeah.
That's totally fine.
On that
Go
note,
ahead.
can we search Pulumi policies and through the search?
Not explicitly, no. It's something that we've been thinking about how we can add functionality for in the future, kind of making like one more global search option. But today, it's just cloud resources that you manage using infrastructure as code.
Fair enough.
It's an interesting use case, though.
Yeah.
I was thinking since we curvetailed a bit to talk about AI, I can tie things back using that. So we actually also have in our resource search, natural language search, which also uses a large language model. And so what this can be particularly helpful for is if you want to search for something, but you don't know what the syntax would be, because, as we've, talked about earlier, there's just like such a broad surface area in this cloud space with all the different resource types across different providers. And so an example of that could be, show me my VPCs if I don't know what the specific type might be. And so then I can search for that, and it immediately translates that to our syntax. And so this natural language feature is trained on our search syntax, and so it can just quickly convert it for you so you don't have to do it yourself. And so from there, we can see all the VPCs across our organization with the different projects and in different stacks. And so another interesting example is I want to see all my virtual machines across all clouds. And so then I don't have to know what they might be called in each cloud. I can just ask AI Assist and it'll generate the query for me. And so just like that, I can see them all across all clouds. You know, for us, it's predominantly in AWS, but it creates the syntax regardless.
Oh, that is awesome. Wow, no, that's incredible. Can you wait, I see GitHub index and issue labels. Do you also track GitHub issues inside search?
Well, we at Pulumi use the GitHub provider. Oops, put that on top of the search. Use the GitHub provider, and so we kind of have a unique setup, but we have issue labels as part of our Pulumi resources.
Okay, so does that help you like track maybe like tickets or like issues that you have open inside of GitHub that maybe turn into feature requests?
Yeah,
Well, I think
exactly.
in
I
this
don't know,
case,
Luke.
one of the things it does, yeah, I think there's a couple of things. In general, the same notion of using infrastructure as code for AWS kind of makes sense for lots of other systems that you work with as well, where you want to in code describe how you want that system configured. And that makes sense for GitHub as well. And so you can see the kind of things we're using here, you know, issue labels and team repositories and team memberships. So we have all of our team membership information, for example. We have a repo internally where we describe, you know, how each person on the team maps into the various other teams, and then we push that out across GitHub directly from that. And so someone can just open up a pull request to add themselves to a given team, and then if someone code reviews that and merges it, then they'll get pushed out into GitHub, and those permissions will get picked up. And so similarly, these issue labels, you know, we want to have the same issue labels across. We manage several hundred GitHub repositories. We want to have the same labels across all of those. Turns out GitHub doesn't have a sort of direct way to do that, but we can build some automation with Pulumi that just says, here, we're going to define this common set of labels, and then we're going to just say that our desired state is those labels exist in every repository. And now if we change those labels or add a new one, we can just update the program and push it out across all 200 repositories at once. And so it's the same idea as everything we've been showing for AWS, but it just applies to, to everything you're using, not just everything effectively that has a resource provider from Pulumi.
Well, good question.
Yeah, that's incredible actually. I mean, I wish I knew about Pulumi years ago. I've been dealing with making labels manually, and now
Right.
I'm allowed to use Pulumi. Yeah, let's go. All of my 2 GitHub projects will now have the same labels. Yeah, no, that's awesome. Well, yeah, we've seen search. I know the other thing we were going to touch on is insights. So what is insights all about?
Yeah, so Insights is like our top level name for a bunch of features that we release that allow you to get quick insight from both your data and be able to just get like help authoring Pulumi. So what Luke showed as Pulumi AI is kind of part of our like Insights like high level feature, resource searches. And then the third kind of pillar of that is data export. And so once we had built this feature for our customers to search over and we did this private beta with them, their first kind of feedback is, okay, can we get this data because it's really valuable and we want to join it with our other data sets in our existing data warehouse. So we have the ability to download this data via CSV. We also have a search API, so you can schedule like, okay, I want every Friday to look at what GPUs are still running, and then I can create some automation to shut them down. So we have a search API, we have the ability to download a CSV, and we have an API to be able to pull this data. And so us internally at Pulumi, we have dumped all of this resource data that I'm showing you here today into our data warehouse, which is we use Snowflake. And then we've built, this is just like a dashboard on top of our Snowflake data. We've built some analytics on top of it to be able to track some of our resource usage over time. And so you can see, like, similar to what we were just talking about with the UI, the GitHub issue label, you can see all of our resource counts in this view from our data warehouse. And we can do some other interesting things like the breakdown by providers. So for us, we're very heavy with AWS and AWS native. We kind of joined it with like our cost sheet just to do a bit of a cost estimate on our various like stacks. We have a breakdown by stack of where all of our resources are. So as you would expect, like our largest is like our production resources, and then it's all broken down from there. We track like update freshness over time using like the modified field on the resource. So we can kind of see how fresh all of our resources are. We can look at things like the hierarchy. So like the parent child structure of resources, how many of our resources are marked as being protected, our AWS provider versions by resource count. So we can understand, what versions we are using and need to support. And then like resource count by department, since we have, the concept of teams in Pulumi service. And so you can imagine all the things that you can do once you have all of your cloud resource data in one place in your data warehouse. You can join it on various things like this to be able to get insight that's most like relevant to your organization.
Wait, just because I'm curious, you said that at 1.9% of resources were protected. How do you define protected? Or how does Pulumi define protected? Because that seems like a oddly low number.
Yeah, so in terms of Pulumi has like a concept of being protected. So if you just like Google,
Nice.
which essentially prevents the resource from being deleted. And so before you can delete a resource in Pulumi, it needs to first be marked as unprotected. So it's just a safeguard and a Pulumi concept. And it was just interesting for us, right? To be able to see like, oh, how many resources do we have in this state? And you can see it in the UI also, but data export is all about like seeing things at a high level view and being able to aggregate them. And there's a lot of fields like this, like in Pulumi, you can have a resource that's in a pending state. We have the concept of custom resources. You can see, if they're marked to be deleted, when they were created, when they were modified. So we have like more metadata that's of a similar vein.
Wow,
I think it's actually one of the interesting things about the search here is like, even when you can, within an individual count, an individual region, you can of course use kind of built-in features inside the AWS console to do search. But as well as being able to do this across all the different regions and accounts and cloud providers, I think there's a lot of additional metadata that Pulumi has about your resources because you use sort of infrastructure's code tool to describe them. And so the relationships between resources, some of the metadata about this protected bit, all these things that Megan is showing here, quite a lot of these are things that, even the project context, like what project does this resource belong to? What stack does this belong to? That metadata is often missing from directly within your cloud provider because there's been all these layers that it's gone through, and you're kind of looking at the assembly code effectively of what came out the other end. But because we're kind of tying into something very close to where you authored this infrastructure, we have all that metadata still. And so you can use that to kind of get these different views and different information about the infrastructure and more easily find that key thing you're looking for, instead of just looking at a list of thousands of EC2 instances and not knowing, hey, what are these things? What project are they actually associated with? Why do I have this? You actually kind of have that additional context to use to help you identify why these things are there.
Yeah, just to give chat context on what that looks like on the AWS side, you would essentially have to define tags for each of your
Right.
resources that define what team they belong to, who created them, when they were created, all that kind of stuff. And then you would have to search on the tags, which it's definitely possible, but using partner products like Pulumi is a significantly better way to trace specifically like team level stuff. We definitely
Yes.
help.
And of course, the
in
ideal is that you use both, right?
Yeah.
Because Pulumi can also, Megan showed off policy, and you can do things like you can have a policy that says all EC2 instances must be tagged. And so then you're going to make sure that not only do you have that project context within Pulumi, but that you're sort of enforcing that those tags get propagated down into the individual resources so that you can use the tools available inside AWS as well. And you can also do things like we have some more advanced features like transformations, which go beyond just enforcing it. And they just say, I'm going to automatically add tags to every resource, right? I'm going to use some kind of methodology to go add a tags property to every resource that supports tags. And now, instead of me just failing your program, I'm just going to, sort of actively modify what happens when you run your program to inject those tags and use whatever common naming pattern I want. And so these are all the things you can do because you have code and because you have the ability to control that in a very deep way. That you can kind of make sure you get all those best practices embedded directly within your infrastructure in a very scalable way.
Very cool.
All right, how are we doing on time?
We have, I believe, 5 more minutes before we are forcibly removed from our from our Twitch space. But
Okay.
Yeah.
Well,
I mean,
I have one more demo that maybe I could do. That's just a sort of a really kind of crazy demo, maybe that just takes some of these ideas with AI even further. So
I was gonna, Luke, I was
minutes,
gonna give one quick last shout out, and I'll
yeah,
give you the
go for
screen
it.
share. We actually
Yeah.
just released today a Slack integration with Pulumi Cloud. So this is fresh off the press, and it's pretty cool. So I wanted to just quickly demo it. Within like a couple clicks, you can set up for your Slack to get notifications from Pulumi, and you can get things like, here's an example of if a preview succeeded or failed, how many like resources were changed, how many stayed the same, and if anything failed, who the user was. And then obviously you get like those quick links into the console. So if something fails, you can help your teammate out really quickly.
wow, that is
Wow.
awesome.
Indeed, hot off the presses. I think the blog post for that just went out a couple hours ago. So
Yeah, absolutely. But yeah, Luke, you had the awesome, crazy AI idea, so let's see it.
yeah, so this one kind of just takes some of what we were showing with the AI tool and takes it kind of one or two steps further. And this one maybe is not the thing you're going to use every day, but I think it just points at kind of what some of the things are that are possible and that we're kind of going to see in the future. So when we were looking at Pulumi AI earlier, folks may have seen kind of there was this CLI as well, and so you can, if you want to go further, try the Pulumi AI CLI. And so I actually have that open here. This is just the Pulumi-AI repo. This is open source. That's where that link went. And what I can do over here is just run npx Pulumi AI. And what this does is kind of take that same interface that we saw in a kind of chat model within the website, and instead kind of has it inside a CLI. But as you'll see, it takes it kind of one interesting step further. So I can do something like, say, I want an S3 bucket, right? Here it's going to have a, you kind of see we have a different sort of progress display. We have to have interesting progress displays because this stuff takes a while. And it's just going to do this from the CLI. But like before, it's generating some code, kind of using Pulumi AI behind the scenes to generate the code. But you'll see right now what the interesting difference is. Instead of it just giving me back the code and telling me, hey, go paste this into your Pulumi program, it actually just goes and runs it. So it now just deployed this, right? It said, I'm going to, that code said I should create this bucket. So I'm going to create that, and then here's the output. And so this is a bucket that's actually now exists. So I didn't have to, go paste that code in anywhere. I didn't have to go do that because I'm logged in, because I have my credentials set. I'm basically giving the AI tool access to my AWS account. This is our dev sandbox that I'm using here, so can't touch anything real. But I'm giving it access to just go, hey, just deploy whatever I ask you for. And you can see, just again, using kind of the Pulumi cloud here, I can go see, hey, here's my bucket, and you can see this really was deployed, and this does now exist inside AWS. The AI tool just completely took care of that for me. And then I can say things like, well, let's go see what was the kind of in this prompt here. Add an index HTML file that says "Hello World" in 3 languages, right? So I can do that. And now it's thinking about how it's going to approach that problem, and it'll just update the code. And because it's updating existing code, it's going to be a set of changes to that existing program. And so when I go ahead and automatically deploy this, it's just going to change the pieces it needs to accomplish that specific goal. And so I won't go through and spend too much time on this, but you can kind of play around with this tool if you wanted to see what some of the really interesting things are you can do when you can just ask in natural language and create infrastructure, not even think about infrastructure as code necessarily, but just have the AI tool go and automatically create that for you.
Wow, that is awesome. So actually, following up on that, does this actually create the individual code files for you in your folder, or does it simply just push the state to the cloud?
Yes, that's actually a great question. I glossed over kind of an important piece of this, which is another really important piece of technology that Pulumi has. So Pulumi has a thing called the Pulumi Automation API, which is a way to kind of automate the deployment of Pulumi programs using a piece of software. And so instead of me running the Pulumi CLI as the way that I deploy programs, I can kind of write a piece of software that says I want to deploy this program. And when I say this program, I can either give it some text that I want it to deploy, or I can give it a folder on disk, or I can give it a Git repo, or I can give it a variety of things. And that automation API is actually what we're using here. So this piece of software, and you can actually, this is all open source, so you can go take a look at it, is just basically a thin wrapper that combines the Pulumi AI capabilities with automation API and just merges them together. So it uses all the Pulumi AI to write the program, and then just embeds that text directly within automation API and tells automation API to deploy that. And so we didn't actually have to store anything on disk here. We can ask it for what the program is. Like you'll see, there's some commands I can run, like bang program, to tell it I want to see what the text is that it's built so far. But we don't have to actually store. We don't actually have to have a program anywhere. We can just let automation API go build and run those on behalf. And this automation API has been something that has seen enormous usage from Pulumi over the last. Oh, looks like we ran into some issue there. So sometimes this does run into issues, and sort of the AI can be a little bit too creative. But the general idea, of allowing this sort of AI to go build stuff is really what we're trying to enable there.
That's incredible. That's absolutely incredible. I mean, so wait, uh, how would how would you actually how would you sorry, completely blanking out. You mentioned the automation API. What is that?
Yeah, so I think it's sort of instead of the traditional way you think about running, Pulumi or any ISC tool is kind of, running it from the CLI, like running Pulumi up, or running it inside your CI kind of tool potentially, like GitHub Actions or something like that. And one of the things we found is that for a lot of folks, especially building more advanced kind of cloud infrastructure solutions, those sorts of human-driven processes, whether it's human-driven at a CLI or human-driven by opening up a PR, are kind of too slow for a lot of automation processes. So a lot of folks are trying to do things where they have software that's actually driving this. So when a user takes an action, like we have customers who, for instance, spin up new copies of their infrastructure for customers when those customers ask for a new environment. And so quite a few managed database providers that use Pulumi to spin up new environments on a per customer basis and manage those. And many of them do this with automation API. So they can build a piece of software that is hooked into their actual production application, which knows to go stand up a new copy of this infrastructure or tear down a copy of this infrastructure based on software and not based on a human taking some action. And so automation API is really a way to sort of embed infrastructure as code, and Pulumi specifically, into your software solutions. And this provides sort of even more opportunities for scale in terms of what you can accomplish with cloud.
No, that's incredible. So is there any way that you can embed, I know this is odd, but I'm asking from a more DevOps side or like a GitOps side. Is there any way to embed human approval in this automation API? I know it's kind of counterintuitive, so you want to have everything go fast, but sometimes I just want someone to say, "Hey, slow down. Let's think about
Yeah.
this before we push it."
No, I think one of the great things with automation API is it sort of gives you complete control. So you can build your own software solutions over top of this. So, you could build an automation API piece of software that kind of runs a preview, pushes that into some context, like maybe that pushes into Slack or into a GitHub issue or something like that, requires some sign off in some system that you manage. And then only once that sign off happens, does it go and actually do the update. And so you can define that workflow in a completely custom way. You're not constrained by your CI system or by anything else. You can just build your own software solution that integrates with the rest of your software to be as creative as you want to about how to solve those problems. I'd say in terms of like doing that as the sort of default model, I think, we want to make that really easy to do so you don't have to be creative for the common cases. And there's sort of two models for that. One is, embedding it within kind of a pull request workflow where, the gate is that someone approved your pull request and allowed you to merge that. And so now the action is taken only on the merge. And so that you can kind of integrate into a typical CI workflow. But then the other one is we didn't get a chance to show it off much today, but we have our own Pulumi deployments capability, which is sort of a built-in ability with the Pulumi Cloud to drive deployments of infrastructure as code solutions. And you can almost think of that as a hosted version of Automation API, where you kind of don't have to run the Automation API program yourself. We kind of run it for you. And in that world, approvals is one of the key things that we're going to be adding very soon, is the ability to, as part of the deployment, actually mandate that someone approve it within the Pulumi Cloud interface. So that's going to give you another option as well on top of traditional sort of Git and GitHub-driven processes.
That is actually awesome. And it turns out I made a slight mistake. We actually have the better part of 16 or about 26 minutes. So if you wanted to go and show off Pulumi deployments, that would actually be pretty awesome.
Yeah, I guess Megan, do you want to show? I guess Megan showed very briefly some of how we're using deployments kind of in our data warehouse infrastructure. But Megan, if you want to go a little deeper and show a couple more examples there.
Yeah, let's do it. Okay, well, I guess taking off from where we last were. Okay. We were looking at Slack notifications, and we also have Slack notifications for deployments. So you can see kind of down here that when a deployment is queued or running, we'll post a Slack notification. And so I can walk through what that actually means. So Pulumi deployments, if we look at a stack that has it configured, is essentially, instead of, it's just a hosted execution for running Pulumi. So if you want to get like something set up with like a GitOps workflow, instead of having to run Pulumi locally, you can have it have Pulumi Cloud run the Pulumi CLI on your behalf. And so that actually runs like on our compute. And one of the benefits of that is there's a couple things. The first thing is you can configure this, and then any of your developers following your role-based access model on Pulumi Cloud can run Pulumi operations from the console. So, let's say you come in here and you just need to run a refresh. You can just do that immediately from this click to deploy menu. But in addition to that, we have this Git flow where we can tie the events of a PR to a deployment. So in this case, we're just updating our Metabase version. And you can see we open the PR to change our Metabase resource to be the next version. And Pulumi will actually run a preview on our servers, showing what will happen when this update occurs. And so then you can see that on your PR. You didn't have to set anything up. You didn't have to, configure your environment. And then you're like, okay, that looks good. And you merge it. And then the update will actually run and your infrastructure will be changed. So, one of the benefits of Pulumi deployments is you configure it to a branch, which I'll show you what that setup looks like. So these are our deployment settings. And if you're using GitHub, you just configure it to a specific branch. And then when there is a pull request on that branch, Pulumi will automatically run a preview for you and then run the update when you push the commit. So this has been, this feature has been growing like really fast for us at Pulumi. It makes deploying your cloud infrastructure easier. And we have, not just this UI workflow, you can also use the API directly. So if you want to set up like your own workflow, kind of what Luke was talking about, where it's like a hosted automation API, if you need to set up a workflow where you have like a customer who joins and then you want to create a stack and spin up all the infrastructure you need for that customer, kind of like an ISV model, you can do that using Pulumi deployments and the Pulumi deployments REST API. So those are kind of like the three main ways to leverage Pulumi deployments is the actions menu where you can quickly deploy from any stack, the GitOps flow that I showed where you kind of see the PR preview and then have that update happen when it merges, and then using the API directly.
Cool. I have a question. I see we are using, GitHub for the source control settings. Is there a way that we're integrated with other service control services, like maybe like code commit or anything?
So today we just have direct GitHub support or just raw Git support. So you can specify like any .git file. Our GitHub support is definitely more out of the box. We use the Pulumi GitHub app to post those nice like comments on your PR and whatnot. So GitHub is kind of our first tier support, but you can set up your own workflows with any raw Git details. We do have on our roadmap plans to support GitLab and potentially Azure DevOps, depending on how things shake out with the rest of the year. But it's something we have heard a lot from customers, so it's a very relevant question.
Yeah, I think the key thing there is we do support kind of the core deployment supports any source for the source control. I think that the piece that is sort of unique and uniquely kind of good for GitHub today are those sort of comments that Megan was showing, the things that actually integrate with the GitHub user interface itself and allow you to kind of push some of the information back into context. And the ability to do that is kind of different in each one of the different source control tools. And so that's something that we kind of need to do in a custom way for each one of those. But the core support for integrating into any Git repository and authenticating against that, as Megan's showing here, you can use all the deployment's capabilities with any place that you're storing your source code.
Sweet.
That's awesome. So you can define custom workflows within just your Git repositories as well. That's incredible. Well, actually, like you should have an excellent example of how you are using it internally. How are some customers using Deploy?
Yeah, I mean, it's been awesome. We released Pulumi deployments in preview last November, and the like uptake has been like really surprising since we released it. We meet with a couple customers a week at least that are using it just to kind of understand and like inform our roadmap. And some interesting use cases is we met with a customer that was like exclusively using Jupyter notebooks to like have a notebook for everything they needed to do, and they didn't have to have any of the like the Pulumi CLI set up. They would just use Pulumi Deployments REST API to create their deployments and run any code changes they needed, which was just like a use case that didn't expect customers to adopt. But we're seeing like Luke kind of talked about Automation API. Automation API has been like a very popular tool for large Pulumi users to scale their the amount that they can do with Pulumi, and we've seen like deployments do something similar where customers are setting up these like large automated workflows, and they're able to have less developers managing more cloud complexity because you're just able to set everything up to be like automated and have it all be based on a workflow. So it's been interesting seeing how customers are using it.
That's incredible. And I know this kind of ties back into the infrastructure as code conversation, but do you have anything planned where you can do like just I want to say static code analysis, but like specifically for infrastructure, where you can say not just through policies, but say somewhere down the line there's some AMI that's now considered just like bad because it's in an older patch or something. And do you have some way to do that level of analysis or planned?
Yeah, I think there's probably a few different things, some of which we kind of have today in some form, and some of which are kind of exciting for the future. I think one is from a pure static analysis perspective, because we use existing programming languages, you can use all the existing static analysis tools available for those languages. So if you have linters or linters with plugin models or anything like that, you can build things into those, build rules for your linting system that identify static patterns that you want to disallow or you want to discourage. And so one of the general answers for Pulumi is, hey, you kind of get a free answer for most of these questions because you get to just leverage the best of what's available inside the language ecosystem. We don't have to actually go invent that in most cases. You can just go kind of integrate with the existing systems, whether that's linters or static analysis tools or package managers or testing tools, whatever it is. And that leads to, I think, the next one, which is it's not really static analysis, but you can write tests, right? And this is something that folks, is not really as common as you might think in kind of the infrastructure as code world, and certainly in the cloud infrastructure world, to think about testing your infrastructure. But I think it's just as important, if not more important, like deploying a bug into your cloud infrastructure can be very damaging and very disruptive. And so being able to validate that the changes you're making really are correct and are going to behave as you want ahead of time is particularly important for cloud infrastructure. And so with Pulumi, you can write tests against your infrastructure. You can write tests that try out, in a couple levels. You can write unit tests that just validate that the logic of your code is sort of doing the thing you expect, that when you stitch together these resources, the resulting thing kind of behaves in the way you want. But then you can also write integration tests that take a whole Pulumi program and say, I'm going to stand up a copy of this thing from scratch. I'm going to run some validation on it, like test that the endpoints are accessible and behave the way I want, and that all the networking is configured correctly. And then I'm going to tear it down. And just every time I want to merge a PR, I'm going to try that out. Right? I'm going to try standing the thing up, validating it, and tearing it down. And that's going to take maybe a minute or two, but I'm going to get validation that this thing works correctly. And so that kind of testing, we do that in all of our provider repos, for the things that we ship. But many of our customers sort of embed those kind of tests into the infrastructure they're deploying. And so it's not static analysis, but it is sort of a way to sort of validate that the thing, is correct relative to your definition of correct in your tests. And the last is, as you mentioned, the policy offering, which you can sort of think of as another class of testing, but that ability to write policies that enforce requirements on your infrastructure. And so, for example, if you had an AMI version you want to make sure you're not using anymore, you can just say, hey, I want to write a policy that says that if anyone tries to use this AMI, I'm going to give a warning, or maybe I'm just going to error and I'm not even going to allow them to do that. And so that's the kind of thing you can do with Pulumi policy and with testing and existing static analysis tools.
That's incredible. Actually, we have a chat request, which is actually awesome. Folderic says, "Can it write infrastructure as code tests?" So if you're feeling particularly confident with Pulumi AI, let's have it write some tests.
I honestly, I don't think it will, but I'm curious because I don't know for sure that it won't. So why don't we try it out?
Make sure to switch to TypeScript.
Oh, I didn't go. Yeah.
Oh, that's fine. We'll learn some Go while it's going on.
It'll probably take a little bit too long, so I don't know. Anyway, so okay, let's try this out. That's gonna probably take a second. Well, one thing we've noticed, we've been using GPT APIs for the last couple of months as part of this, and certainly the performance of these APIs differs at different times of day. And so you probably noticed that sometimes it's a little bit slower, sometimes a little bit faster. That's something that is currently outside of our control. But
yeah,
see what it comes up with.
Yeah, I'm honestly interested, or if over the next couple of months, years, however long it takes, if we can get like lightweight LLMs that can go on device, because a lot of devices that we use right now, be that phones or laptops, have some kind of neural accelerator built into them. It'd be cool if it could use part of that on-device compute as well.
Yeah, and I think it's one of the really interesting things that we're kind of looking at. One of the interesting reasons, we use GPT-4 here, which is obviously a bit slower, but it's very, very, very good at writing code. Right? It's pretty uncannily good at writing large amounts of code, which is really critical for the experience for this specific tool. But we are looking at and validating a few other models that we might be able to use, which are also good at writing code, but maybe have better performance or able to run locally, potentially even able to run in the browser, which might be a possibility in the not too distant future. But well, it looks like it didn't add any tests, unfortunately. So
maybe
it'll come up with something dangerous.
Yeah.
But we've not designed this to help with the test writing part yet. Oh, here we go. It's gonna write a unit test.
Oh, okay.
But we've not designed it for this goal, so this will be going a little bit more in that creative realm. But it's one of the really fun things building tools in the space is that they're able to be really creative within the kind of bounds that you've set. And if you don't explicitly say not to do something, they will try their best to do it. This is another great example of, hey, if I want to learn how to write, tests, can kind of get the AI tools to sort of help me with that as well.
Yeah. Oh, wow. It's writing better tests than I am already.
All right, this will probably take a few seconds, but
Yeah, hey, maybe this is the new feature request for Pulumi AI. Write modular unit
write my
tests for
tests. Yeah,
yeah, write your
no,
tests.
it's actually a good point because I think it's what we're showing off here is kind of the things we support today. But really, I think we see just you can just look at these things and see all these opportunities to take all these ideas even further. And so I think there's so much more that we want to do. There's so much more I think that the industry is going to do to take these tools and really use them to enable better developer experiences, both for what we're doing, it's for kind of cloud and cloud infrastructure. But I think the opportunity to use these to improve the developer experience in so many domains, we're barely scratching the surface still, and there's so much more opportunity here.
Oh wow, it's actually doing it. That's incredible.
Yeah. So I guess it's validating that the instance type was a T2
Is
micro,
correct.
right?
Yeah.
Yep, there you go. And this isn't super simple code to figure out how to write, right? There's a little bit of interesting structure here, even beyond just how to use Mocha and Chai and those existing things, is kind of how to test Pulumi programs. And so this is kind of really interesting. I actually don't know if this is exactly right, but it's a good starting point. You could at least try to run and see if you run into problems and ask it to go iterate on.
And it's recommending you install Pulumi test. Wow.
Yep.
Okay, there we go. That's brilliant.
That's amazing.
Alrighty.
Wow.
Yeah, well there we have it. Pulumi AI, it writes tests for you. Oh wow, that's absolutely awesome. I don't believe we have anything else on the deck. But if you have any final points for Pulumi, if you have any blog posts that you'd like to share with the team, please send them to me and I will send them out. But yeah, it was awesome having you on. I believe all of our handles are in chat, so expect a riot in your DMs. And we'll see everyone next week.
Sounds good. Thanks, everyone.
Yeah. No, thanks so much for having us. Great to get a chance to talk through this stuff, and thanks for everyone who kind of had some questions and some interesting prompts to go try for the AI tool there. You can really I just say go to Pulumi.com, check out everything. You can check out the Pulumi Cloud, you can check out the AI tool, you can check out writing ISE with Pulumi. Definitely encourage anyone building complex things in the cloud to check out Pulumi. I think there's a lot of tools that you'll find useful there. So thanks all for joining.
Awesome. Yeah, we'll see you next week. Thanks a lot, Luke. Thanks a lot, Megan. Thanks a lot, Patrick. You've been an awesome set of co-hosts and guests. And welcome to Howdy Partner once again.
Thank you.
Thank you so much.
See you next week.